Let me start our seminar today. Again, this seminar belongs to the series of FJelinekSeries lectures, and I'm very happy to welcome here two of our guests, Professor Barbara Moser-Mercer and her colleague Alexis Hervé Adelman from Geneva. And I should say that I have listened to Barbara's talk she had an invited talk for Coling in Mumbai last December, and the talk had a very good response. So I thought that we also should take advantage of her willingness to come to Prague and to give us a talk from her specialization, especially when she is on the way, or her talk is on the way to brain or cognitive skills, and I think this is one of the fields we have not yet explored very much, but we have to take into account as well. So, take the floor, please.
Thank you very much, Eva. Thank you for the invitation. Thank you for the marvelous hospitality. We have already been quite spoiled. And not just by Czech cuisine, but mostly by Czech cuisine. So we hope that in the next hour we can keep you warm and engaged. We've divided our talk in two because we are complementary in the ways in which we are working on what we hope to be a theory of expertise that integrates also the neurophysiological evidence. Up until now, expertise theory has been mostly behavioral, and now we're beginning to see data confirming certain hypotheses that had been advanced in expertise theory, that is how people learn to become experts in different domains. So the idea of the talk today is to give you some of the fundamental neurophysiological evidence, and then we're going to move on to looking more specifically at interpreting as one instantiation of a complex skill, a very complex skill, and then we're going to suggest some elements of what we consider to be the beginnings of an expertise theory that hopefully at some point may also extend to other domains outside of interpreting. So that's kind of the overall framework of the talk. Alexis is going to start. His specialty is cognitive neuroscience. I originally come from psychology, but then moved on to interpreting. I'm a simultaneous conference interpreter, and yes, I still work at the UN. I still do a certain number of days to make sure that I remain an expert in the field and know what I do when I train. But what brought us together really was a Swiss National Science Foundation grant to explore the neurophysiological dimensions of simultaneous interpreting. So I'll hand it over to Alexis. He's got his microphone on, and then I'll take over the second part.
Okay, so I hope this isn't too far unusual and out of the field that you're used to hearing about. I hope it's going to be somehow exciting for you all. So what I'm going to do is try and lay the groundwork for Barbara's theories. So what I'm going to do is to start by talking about bilingualism. So very, very generally, bilingualism, the mastery of two languages in one brain, is quite a problem actually in theory for how we can use both of them successfully. So what's actually been examined with bilingualism is the idea that bilinguals who have a real mastery of at least two languages have a form of expertise with their languages. They manage them very successfully, and it comes just naturally. And what seems to be sort of a correlate of this is that there are really some broad cognitive consequences. Now, the exact nature of these has been a matter of debate for many decades, and I don't want to get too deep into that sort of struggle. What I want to just talk about is to summarize the evidence, some of the evidence, for the fact that being bilingual seems to improve a specific subset of cognitive faculties, which are known as executive functions. And these are things like action selection, action inhibition, the control of attention, and working memory functions. And I just want to demonstrate some of the tasks where these things have actually been proven to exist as advantages for bilinguals. So one of the more recent demonstrations here in children, sort of 8-year-old children, was a test known as block design. In block design, you're presented with a picture of a little image here, and you have to recompose it with these blocks. And that actually requires you to analyze the global pattern, but really to break it down into the component blocks. And then it tests the ability really to control your attention, to focus on local features rather than global features. And it turns out that bilingual 8-year-olds, and this was done over several combinations of bilingualism, are faster at this kind of task than are their monolingual counterparts who are matched for socioeconomic status and for their sort of schooling, etc. That's one demonstration there in children. Another demonstration in slightly older children is another test that looks at global versus local attention or focus. And here, this is something known as a Navon letter. And a Navon letter is a big letter composed of smaller letters, and it can be either congruent, here is an H made of H's, and here is an incongruent version, an H made of S's. And the typical task that people are presented with when these letters are used is either to name the big letter or to name the small letters that compose it. And there is usually a cost associated with an incongruency. And the data that were acquired in a large group of, I think they were 10-year-old children, shows that essentially bilingual children suffer less in the face of incongruent letters than do monolingual children. And this is quite interesting because it really suggests, again, something about this control of attention being superior in the bilingual children. And these are children, so they're not people who have spent ages practicing their attentional skills. They just happen to be bilingual. They're not even deliberately bilingual. They just grow up like that. And what's interesting to note here is that the bilingual subjects are in stripes. They are always faster than their monolingual counterparts. And this implies something very general about the bilingual brain being potentially more efficient in some ways. And this kind of evidence is very compelling and very interesting and suggests that there really is this kind of bilingual advantage in a gross way. And this domain of attention is one, but it's been extended into others. So a really rather nice study that was done a few years ago that looked at two groups of 100 people, so 100 monolingual people and 100 bilingual people. These were young adults between the ages of 18 and 30. And this looked specifically at different attentional subskills and something else, which is conflict management. And I'll explain how in just a moment. So the task that was used is known as the attention network test. And what happens in this task is you'll see a series of images. One is just a simple fixation cross. Subsequently, there will be a fixation cross and potentially some kind of cue. And this cue has various positions. I'll talk about those in a minute. Then the cue disappears, and you see a series of arrows. And these arrows can be either all pointing the same way, or they can be an incongruent arrow, or they can be a kind of neutral condition. And your job is always to say what direction the middle arrow is pointing in. And this is associated with a cost when there's an incongruency. So generally, you have a response, you see all the arrows pointing to the left, and then you see an arrow pointing to the right, you're supposed to press right, but actually you have trouble doing that, and there's a slower condition. Now for the cues, there's something very interesting in this task that manipulates your attention prior to the appearance of these arrows. And that's that the cue there can be either congruent, as it is in this case, or it can be just central. Or it can be sort of in two possible positions, which is not necessarily very useful, or it can be absent. And by comparing the impact of these various cues, these researchers have been able to separate various components of attention. So what you have here is the sub-skills of attention known as alerting, orienting, and then conflict, which I wouldn't consider a part of attention, but they maybe do. So alerting is simply what happens when your attentional mechanisms are switched on. Suddenly you become generally faster and more receptive. Orienting is where you're very specifically cued to where something is going to be. And conflict is where you have congruent and incongruent arrows. And what we see here is that in two of these sub-skills, the bilingual groups are better. So in terms of alerting and in terms of conflict management. So that sort of narrows down some of the skills that the bilinguals are better at. However, something that's also important that comes out of this research is that in general, these are reaction time graphs, so lower is better, the bilinguals are faster than their monolingual counterparts for every possible condition. And this again points to there being a kind of general bilingual advantage that isn't necessarily limited to very specific attentional subcategories. And that's where this debate becomes very, very thorny, and people sort of say bilinguals are better, no, they're not. It gets very, very nasty. And we stop with that kind of thing. But just to add a couple more kinds of tasks where bilinguals are advantaged, there was another piece of research by Yellowstock and her colleagues using a Simon task. And this is a task that implies the management of response conflict. And what that means in this context is basically you would be presented with a screen on which a shape appears, and the shape should code where you have two buttons. The shape should code which button you press. So for instance here, the triangle says, right, you must press with your left hand the response. But when it appears in the right half of the screen, that actually has a cost. Basically, you have to attend to the local features rather than the global features, and you can't use the position to cue you anymore. And this is again a domain in which bilinguals are shown to have an advantage. I'm just going to give you one more example of a task where there's a bilingual advantage, and I think you probably get the general point. And this is the Stroop task. And the Stroop task may be familiar to many of you. In this task, what you have to do is to name the color of a series of colored words. Here, this is easy. I mean, in one's mother tongue, it's easy anyway, and the words are congruent. As soon as they become incongruent, however, there is a cost, again, associated with having to name the color, because we're unable to suppress the impulse to read the word. And we automatically read and understand the word, and we make mistakes. We constantly make mistakes about naming the color. I mean, that's a very interesting demonstration of the potency of reading and how automatic it is. But more importantly, it's a demonstration of the need to control one's attention to different features and the fact that there's conflict. So again, it's a kind of conflict management task. And here, this was done with older and younger bilinguals and monolinguals, and the main finding here was that in the older bilinguals, but not so much the younger bilinguals, there is a reduced cost of incongruency. So this is another domain where this bilingual advantage appears. But again, here it's only happening in one subgroup. So it's in the older bilinguals that it's apparent. And this is quite often the case that in sort of younger bilinguals versus younger monolinguals, it's quite hard to find the cognitive advantages unless tasks are extremely hard and extremely demanding. So there are other tasks where bilinguals have an advantage, but I'm not going to hammer those home too much. Just to say that there have been demonstrations that bilinguals can maintain a task set more efficiently, and that generally switching between tasks has a lower cost for bilinguals than it does for monolinguals. And something else that I think is really worth emphasizing is that there is potentially a long-term consequence of bilingualism. And in aging, there's been a lot of research recently, there's been a lot of focus on this research that shows that essentially the bilingual population tends to be preserved from the symptoms of dementia. Now, this is in the case of Alzheimer's disease, and what the evidence seems to point towards is that it's not necessarily that bilinguals don't get Alzheimer's disease, but their brains can actually take more damage before the symptoms appear. So the disease can be in the brain for longer, it can be really, really eroding tissue, but it takes much, much longer before the disease symptoms become apparent. And this cognitive reserve that bilingualism seems to produce is something that's of great interest for us, because obviously it has implications for whether we should train children in multiple languages and so forth. But also, potentially, it links anecdotally to some reports we have of simultaneous interpreters who are also experts in language control, who seem to be able to continue working very efficiently until they're well past the standard ages of retirement, their 70s, and some into their 80s. Now I want to take a break from all of this evidence, and I want to start talking about how this is manifest in the brain and the networks in the brain that are involved in all of these sort of executive functions. And again, I'm not really sure of everybody's background here, so I'm going to try to keep the neuroscience terminology as comprehensible and light as possible, and I hope I'll manage. So the first executive function that I'd like to talk about is inhibition. Inhibition is something we're all familiar with. If you start an action and you need to abort it halfway through because something has happened and that's no longer an appropriate action. It's something that we need to do both physically when we make a gesture, and it's something we need to do both mentally when we have a cognitive operation that suddenly needs to change because the context has changed. And there's quite a lot of work looking at this, and it exploits various tasks. But here is just a nice, well, very blurry, nice graphic showing some of the network that's involved here. And the nuclei that are really involved is some of the prefrontal cortex here, this sort of region known as the pre-supplementary motor area. There's regions of the right inferior frontal cortex, which just happens also to be implicated in the processing of prosody, which is interesting. And here the subthalamic nucleus, which is a part of a set of very, very core nuclei called the basal ganglia, which are kind of the essential input-output structures for all of motor patterns and motor programming that needs to leave the brain and be executed by the limbs. So that's a kind of inhibition network, and inhibition is one of these skills. Now another is something, so the general thing is conflict, and conflict is obviously when there are two possible responses, when there's the possibility of making errors. All of this seems, in every one of these little dots, is the center of one of the peaks that's been found in neuroimaging analyses up to 2004, looking at the center of conflict management. And it seems that this is a slice through the middle of the brain. I hope that's clear. And this is the front, and this is the back of the brain. And this region that seems to be heavily involved is a complex known as the pre-supplementary motor area and anterior cingulate, the pre-SMA ACC complex. And this is a very interesting region because it does seem to really heavily load on these tasks. Now, some of the other regions that are involved in these general executive tasks are things that are involved in attention, of course. And attentional control is something that's very, it's very ill-defined because we have trouble defining even what attention really, really is. But it's interesting, there's enough work that kind of coalesces around these particular networks that really talks about the orienting of attention, so the response to stimuli or task demands, and the executive control of attention, which is what you do when you have to think about how to focus your attention because something is going on. And then what I'd like to come back to, these regions that I mentioned before, these very core nuclei, the basal ganglia. And this is just a nice image that illustrates their situation within the brain. These are horizontal sections taken roughly through the middle of the brain. And these colors of each of these represent where they're connected to in these basically prefrontal and frontal regions. So a lot of this is motor cortex. This prefrontal region here and this orbitofrontal region here, they're not implicated in motion. They're implicated in what we can think of as thought and very high-level cognitive processes. And the fact that these regions are connected both there and to the motor cortex suggests that they have a very, very crucial role in gating the execution of sort of what happens when you think an action to executing it. They kind of mediate this sort of process. And they're implicated in a wide range of cognitive functions, really everything. Learning, motivation, memory, action sequencing. They have some implications in language. They're very, very interesting structures. And I'm going to try to focus a little bit more on their language functions, basically. So looking at bilingualism, this is a nice meta-analysis of a bunch of studies that have been done on language switching tasks. So obviously a language switching task is one in which you ask a participant to respond in one language to one type of cue and respond in another to another type of cue, and you analyze the difference in brain responses that occurs when they have to switch from one to the other. And there's a lot of interesting research done about the directions of task switching and how that changes the networks that are involved. But what seems to be very, very crucial, at least in the context of what I like to talk about, is these two blobs here, which are in the chordate nuclei bilaterally. And these are the same structures that we saw a couple of slides ago. They are these nuclei here. And again, I just reiterate that these are connected not just to motor areas, but to prefrontal, orbitofrontal regions that are more cognitive regions. And the chordate nuclei have been shown as well to be involved in tasks that involve translation. There are very few such tasks, but those that have been carried out under brain imaging conditions have shown that the chordate and neighboring structures seem to be implicated when languages need to be sort of accessed one to another. And then here's a very nice summary of what I've just been talking about by one of the great names in this field, Jibin Abitalebi and David Green. And this is basically just showing what they consider to be the core language control network in bilingual brains and separating them out into the sort of different neuroanatomical correlates of things that I've been trying to summarize. And so I think this is I'm not going to talk through every single piece of this because I think I've probably said enough about the subcomponents, but really just talking about the link between executive functions and attention control and all of these things that are really very, very domain general, and the fact that there's language control is somehow in there as well. And the fact that being bilingual seems, as a result of practicing using these structures all the time in order to communicate, seems to enhance these functions. And that's something that we like to think about the brain. It's like a muscle. You use it, it gets better. The more you practice something, the more you can improve it. And this sort of bilingualism is this inadvertent expertise that has honed certain subcomponents of the executive skills. So just to summarize really that bilingualism appears to affect regions that are crucial to all of these executive functions, cognitive control, learning, memory, motivation, sequencing, and really even down to habit formation, very, very low-level structures. And we think that maybe training in simultaneous interpretation could improve the efficiency of these structures as well, because simultaneous interpretation, of course, is something that really demands high-level language control. It's really something you have to learn. Not every bilingual can be an interpreter. It's not as easy as that. And so this asks another question, which is there a simultaneous interpretation advantage? Are people trained in simultaneous interpretation advantage in these domains? And we tested this, not explicitly. We started to look at what are the brain systems involved in simultaneous interpretation, because no one has really done this before, and people have shown, as I said, language switching evidence. But language switching is one thing, and yes, we do it, you code switch from time to time, or you speak to people who speak different languages and you change language. But simultaneous interpretation requires a very, very different kind of ongoing language control. And there's a lovely summary of that, which I'll just quote from Professor Moser-Mercer's work, which is processing the source language while simultaneously interpreting and monitoring production in the target language, respecting the phonetic, semantic, syntactic, and prosodic rules of this other language in real time. So this is really something that demands a lot. It's not even just language control. It's understanding, it's controlling the motor system. It's an awful lot of subcomponents. And so we took two groups of trainee simultaneous interpreters for a total of 23 participants and some multilingual controls who were also able to do this basic task that we set them. And they had a variety of mother tongues, and they're all interpreting into their mother tongues. And we asked them to carry out an interpretation task in the MRI scanner. So basically, the MRI scanner is a not very pleasant environment. It's a confined kind of tube space that makes a lot of noise, and it's a little bit claustrophobic. And what we asked people to do was just interpret brief series of sentences, and then we acquired an image of the brain's activity after that, and we repeated this for about 35 minutes. And that, I think I'll skip over the exact methods because we're going to be short of time. But what we did was to compare the brain activity while people are interpreting, the brain activity while people are simply repeating intra-language what they're listening to. And we also compared that to a much lower level task, which is listening. So we just had them listening. So what you see in blue on this brain here is the neural correlates of shadowing, which is just repeating within language. No conversion of the message is necessary, compared with just listening. So we're ignoring the sort of low-level effects of hearing stuff. And in red, what we see is the additional regions that are implicated when people are carrying out interpretation. So I think the really crucial things to draw out here are that the regions involved specifically in interpretation are these inferior frontal regions here, which are implicated in not just this, they're very implicated in language, sort of semantic stuff, phonological working memory, and also potentially some level of cognitive control inhibition. Here particularly we see activity in this sort of this SMA, pre-SMA anterior cingulate cortex, which is very, very important for conflict resolution, conflict management. And what we also see, which I think is particularly interesting, is a lot of activity in the basal ganglia. We see particularly something that's not so exciting in something called the globus pallidum, which is a kind of input-output, just of motor outflow essentially, where things are equally active during interpretation and shadowing. But bilaterally in the chordate nuclei, we see a hugely elevated amount of activity during simultaneous interpretation. And the chordate nucleus, again, I remind you, is something that's involved in lower level, very, very general cognitive control and not specifically language. And it's very, very interesting then that simultaneous interpretation should load so heavily on this structure. And here, just to try and put that into a possibly more comprehensible sort of three-dimensional context, this is just the activity projected on a brain rather than slices of the brain. So another question that we wanted to ask is really the management of simultaneity. This is the really, really tough part of interpretation. I mean, anyone who masters two languages can probably take notes and then convert one message to another consecutively. That's less demanding. But simultaneously, this is really where the challenge lies. So what we did was, during the interpretation in the scanner, we recorded people's productions, and then we calculated the amount of time for which they were simultaneously hearing continuing input and producing speech. And that should be really something that's very, very hard. So what we looked for in the brain is regions whose activity was modulated as a function of the amount of overlap that there was, trial by trial. That's jumped forward. And what we find, in fact, is, okay, I hope, these are again slices about midway through the brain. What we have here is auditory cortex, and we find the auditory cortex is modulated by the simultaneity, and that is fairly trivial. Obviously, a more complex signal is going into the ear for longer. Okay, that's, it's pretty, but it's not so exciting. What is exciting, however, is, again, in these core subcortical structures here, we see bilateral modulation of the putamen. And the putamen is a structure that is involved in, let's say, the control of habit. So inhibiting things that are habitual. It's not cognitive inhibition so much, but really the control of things that are very, very automatized. So what we see is a distinction there between the chordate nucleus, which is a kind of cognitive control nucleus, and the putamen, which is not so much cognitive as just habitual. And this is particularly interesting because we've been able to separate these two functions in the brain. So I'm going to leap over this summary, but just pause there to say that something we're interested in, obviously, is how does the brain change as our simultaneous interpretation trainees train, as they improve, as they acquire this skill. And so we rescanned them doing the same task after they'd finished their 15-month masters in conference interpretation. And we looked for regions where the amount of activity in the brain during interpretation has changed as a function of training. So we compared with the control group, and we looked for where things were specific to the interpreters. And I'm not going to pause for too long on this, but what I'd like to point out really specifically is that, again, in the chordate, this is a very, very central structure, we find a specific decrease in the level of brain activation that occurs during simultaneous interpretation. And that's something that you often see. So for expertise, basically, you find decreases in the activation of core regions as they are thought to become more efficient. It requires less neural effort to actually do the same task. We also see some other changes. Particularly, this region is worth mentioning because it may well be implicated in the control of attention, although that's a bit controversial, let's say. Something else we looked for, which is potentially very interesting, although it's difficult to describe, is changes in the structure of the brain that relates to training and interpretation. And what we find here, it's, as I say, it's difficult to characterize, but it's a multivariate pattern that is expressed only in the simultaneous interpretation group and not in the controls. And what we find is there's basically a specific brain change that can be used to accurately determine whether a given brain belongs to the group of trained interpreters or not. And that's interesting, although I can't really tell you which regions are specific to that because it's a hugely distributed multivariate pattern over the whole brain. Now, this then takes us back to this concept of interpreter advantage. And does interpretation actually give the interpreter an advantage? And a little bit of behavioral research that has been done on this suggests probably that it does. And specifically, one thing that seems to be benefited is the phonological loop. And the phonological loop is something that maintains representations of speech input. And this is unsurprising because that's something that interpreters need to do all the time while they're executing interpretation. And here I just cite some studies that show that there is basically certain advantages. And I'm not going to focus on that too much. Something that is quite interesting and related to that, though, is that according to one study by Köpke and Nespoulos, there seem to be greater advantages for novice interpreters than for actually professional interpreters in this same phonological loop. And that's possibly because the novices need to use that more than do the professionals because they haven't automatized the task as much, although that's an open question at the moment. And something I think that, we should point out is that beyond just working memory, there has been a little bit of research that shows that interpreters have enhanced cognitive flexibility, but not specifically better inhibition. And that's probably consistent with the changes we find in the chordate nucleus, which really is involved in juggling multiple cognitive sets simultaneously. And we like to characterize it in these contexts as being something that is responsible for basically maintaining two languages live simultaneously. So, just to sort of wrap up what I've got to say really is that learning to interpret then, it requires the enhancement of all of the necessary subskills of the task. Now, it's not to say that everyone can become perfect at every required subskill, but they need to make them as optimal as possible. And bilinguals already have some advantages of the attention, the inhibitory control, conflict management, and being a good interpreter, though, it's not just these functions, it's more, and it seems to actually enhance them yet further. I think that's something that's potentially a great source of, well, a rich seam of research for us in the future anyway. And with that, I'm going to hand over to Barbara. I think maybe if there are any questions on that, it might be a good time to take them before we add more to the pile. So if there's anything that wasn't, I'm sure there was lots that wasn't super clear, or anything specific. No.
All right, we'll switch over now and basically move to some of the behavioral evidence that we've collected on how people become experts. And not just in interpreting, but obviously I will focus on interpreting simply because we've laid a foundation on bilinguals and the advantages that they have. But our ultimate objective is not just to understand what makes an interpreter an expert and how they become experts, but are we beginning to be able to identify certain regions in the brain that might be responsible for expertise in other areas as well. So somebody who becomes an expert programmer or somebody who becomes an expert in just about anything, the pianist, the dancer, are there similarities across various areas of expertise? And I think this is, in the end, probably just some hypothesis we're going to throw out as we're working on the beginnings of a theory of expertise, the way we are beginning now to integrate the neurophysiological evidence and the behavioral evidence using simultaneous interpreting as our example. So with that, I'm taking you back to some other areas. And I think perhaps we are a good example of what interdisciplinary research can produce. It does mean that we all need to start talking more or less the same language. We need to understand, the concepts that each of our fields has put forward. Otherwise, we're not going to be able to communicate. But I'll add a few more. I'll go into learning theories as well, because I am basically involved in the training of interpreters. And over the years, I had to figure out, a good way and even a better way and a more efficient way to train experts in simultaneous interpreting. But one of the things that has come out very clearly from our research, and something that we've also known probably from the past, is that it is not that anyone is born to be an outstanding expert. And there's some very interesting research now going on in the City of Music here. It's not going on here, but that is probably of interest to you, that the Mozarts and the Beethovens of this world had a very, very nurturing environment. They had to practice and they had to work very, very hard. Yes, there was a lot of raw talent, but the raw talent alone didn't make them the Mozarts that we know of today. So yes, indeed, that is encouraging, because what it means is that ultimately, with a great deal of the right kind of practice, we can become experts in different fields. And of course, it's easier if we have a good talent to begin with, but it is not the only criterion that is responsible for developing high-level expertise. The fact that the brain is plastic, I think, was very nicely shown by Alexis, even in the course of 15 months, which is, I think, still one of the only studies that I know of where expertise development has been followed up on over such a long space of time. Most other studies in cognitive neuroscience that had to deal with expertise took maybe a couple of hours of learning on a very specific task, and then they measured the difference, whereas we measured the difference over the course of 15 months, which is a fairly sizable stretch of time, but that is usually the stretch of time. Anywhere between 8 and 15 months is what we know we need at the graduate, postgraduate level to train experts in simultaneous interpreting. So knowing that the brain is plastic, knowing that there are changes, confirms a lot of the anecdotal evidence that we have in interpreting, where students, leave our program saying, well, our brains have been rearranged. And it's also perhaps true, and some of my colleagues, have also confirmed that the moment you've become an expert interpreter, you no longer listen to discourse the same way that you used to listen to it before you became an interpreter. You've already taken on all these strategies that you need in order to survive on the task, but you can no longer go back. And it produces some rather interesting results in experiments where you would think that shadowing, just repeating in the same language, should be much easier than simultaneous interpreting, and you would also assume that those who've been trained in simultaneous interpreting should be better at it than the newcomers. Well, our results show exactly the opposite. The simultaneous interpreters are much worse at shadowing than the students are, because the brain has not really changed as much in the students yet. They are still able to focus on a very specific task, but the moment you've become an interpreter, you no longer approach listening to discourse and repeating it exactly, because you're transferring messages. You're no longer repeating exactly what you hear. So there are some interesting, results that at first sight seem contradictory to us. But now that in the light of expertise theory and the way we understand the development of expertise are making a whole lot of sense. So, this is just a confirmation. No, it's not just being gifted. It is really also applying yourself in what I conceive of as kind of a triangle. Where performance is ultimately what we're after. Somebody who is able to interpret simultaneously for a certain period of time without making, too many mistakes. Mistakes are unfortunately part of the task execution because the outside conditions aren't always ideal. But performance is what we're after. The first thing that we're looking at is the kind of capacity that the students bring with them. That is proficiency in the languages, first and foremost in the native language that they work into, but also in the other working languages. It is the opportunity, which is our job to provide in a university setting. We provide the opportunity. There isn't much we can do about capacity other than checking for it. But then the big part, equally important as all the other circles, which is why they're the same size, is the willingness and the motivation of the student to stay on task and continue with the training, irrespective of some of the setbacks that one obviously experiences. So simultaneous interpreting, as Alex has already said, it's a hugely complex task, and I haven't really put everything up there. But anything from auditory perception to word identification, syntactic and semantic analysis, chunking into units of meaning, transferring chunks, activating the target language and producing the target language, and the list can go on. It would just not fit on a particular slide. But these are obviously the kinds of sub-skills that in your research you're very familiar with. We can add yet another level of complexity, and that is simultaneous interpreting with text, when we have speakers reading at top speed. And this happens usually at the UN now, and many of the international organizations, where they read a text at top speed, and you still have to check against delivery. Sometimes you don't even have the text, but if you have the text, then there's also visual and auditory perception, and you're going to have to match what you hear with what you see, and then interpret at the same time. The speed is mind-boggling, and it's one of the most difficult types of tasks that we have to do as simultaneous interpreters. So capacity I talked about, the proficiency in the languages, but also world knowledge, and I'll come back to that. Knowledge about the world, knowledge about what is being talked about, that we cannot start with a blank slate. We have to start with a certain amount of background knowledge. But it's more difficult than that. And this is, I think, where the generations of students that we are now getting are having difficulty. Much of their knowledge, even if it could be quite comprehensive, is not as well structured as the knowledge was that our generation still acquired. They often have lots of bits and pieces, but the connections between the bits and pieces aren't always there. They don't really see the forest for the trees sometimes. And in interpreting, that can be extremely time-consuming and resource-consuming, because It's all about, listening and making those connections very rapidly. Trying to follow somebody else's thinking online, in real time. You don't have time to listen, and you don't have time to go back. What's gone is water under the bridge, and you need to move on. You cannot afford to go back because there's nothing to go back to. The speaker goes on. And so what you've lost, and you better move on. There's no way you're going to... You can correct at sometimes you can correct, but most of the time, you can't really go back. So opportunity is where we put in an awful lot of thinking about what is the ideal environment in which we can train this task? What do we need to put in? How much do we have to know about the task itself in order to optimize training? Because just like you, there's increasing pressure, financial, budgetary pressures. We have to do more in less time, but then the capacity has not increased substantially. So it's all about making training as efficient as we possibly can make it. Which leads us into trying to figure out, simultaneous interpreters are experts in their field, but there are plenty of other experts around. They could be, pianists and runners or cyclists or chess players. So they're the one category that's been most studied for expertise, chess players, as a matter of fact. And then there are some other categories, but pianists have been studied, athletes have been studied, many different types of sports. So in order to really figure out, what is the ideal way to develop this expertise, we need to have a theory that will explain to us how to go about it. And the theory itself really needs to account for the differences in the resource intensity of different subskills. I had this graph before where I showed you there are different subskills that the interpreter needs to be very proficient in, whether it's just, the comprehension, syntactic analysis, semantic analysis, etc. So these subskills all are resource intensive. And making them less resource intensive is what developing expertise is all about. The less they consume, the more resources you're going to have available to juggle all of them in real time. This is the thrust of expertise theory, and this is where we see a kind of a horizontal comparability across different types of expertise. If, the first time you learned how to drive a car, you didn't just sit down and turn on the engine and drive. Probably, somebody showed you, where the clutch was and where the gas pedal was and where the brakes were and, the steering wheel and everything else. And you did become familiar, even if it didn't take you very long, but you had to become familiar with the different parts before you put it all together. And I think probably one of the things that took longest was, to shift into first gear from, the constant playing around with the clutch and trying to figure that one out. So the sub-skills, the more resource intensive they are, the more conscious attention they require. And the more conscious attention they require, the more time you're going to have to spend on them, and you're not going to be able to juggle many of them. But the less, the more routine not the more routine they become, but the more skilled you become in each of these sub-skills, the more time you'll have left over to juggle them all. The theory of expertise also needs to account for how these improvements in the sub-skills free up the resources. When you have a class full of learners, by definition, in interpreting at least, if I have 10 of them in the classroom, I have 10 different sets of strengths and weaknesses. There are no two students who come in with the same exact distribution of strengths and weaknesses. One of them might be strong in his or her native language, but perhaps a bit weaker in one of the passive languages. Another one might be slow in producing speech. Another one might have some other, knowledge disadvantage. So there are different sets of strengths and weaknesses, and how to, get them all going in the same direction and ultimately up to a level that is acceptable. A theory of expertise also needs to be able to explain to us. And we need to be able to account for improvements in performance. Not all of these sub-skills that we mentioned make the same demands on resources. We would assume that producing language in your native language, by the time you get to that graduate level,
it ought to be, almost automatic, right? It is not automatic necessarily for an interpreter who needs to work into a passive language. And I mean, this is very much the case, and has been the case for the Czech language interpreters in Brussels. In the beginning, when they came, they all had to work from Czech back into one of the more, widely used languages, whether it's French or English or German. There you could perhaps count on a little less automaticity because it is going into your foreign language, whereas into your native language, you would assume there are less demands on that. Working on a conference in let's say, on patents, by definition is more knowledge intensive, knowing all the details about a particular patent than a more general political meeting. There are other challenges in a political meeting, but the technicality of it and the knowledge that you need to come in with is obviously different. There's different kinds of noise. It can be fast speech, it can be accented speech, it can be real noise in the installation. People rustling documents in front of the microphone. I mean, there can be different kinds of noise that makes it more difficult for you to execute the task. So the kinds of changes in the brain as expertise develops from the moment you start as a novice and you move on to becoming an expert is really also what Alexis already mentioned before, changes in the activation. Usually the more activation, the more active your brain is. And no, you don't want that. You can't afford that. You cannot afford high levels of activation in each sub-skill. You would not be able to juggle them all. So you need to begin, to get to a point where your performance in each of the sub-skills becomes partly automated, but efficient enough to reduce the level of activation and free up the resources that allow you to multitask. And this is probably the first time I'm using now the multitasking idea, because it's the one thing that really is responsible for the development of high level of expertise. Being able to juggle things and several things at the same time is not just a characteristic of interpreting, it's a characteristic of any type of expertise, being able to juggle several things. So there are substantial reductions in the posterior part of the brain that are related to attentional control. When I comprehend as a simultaneous interpreter, I don't comprehend the same way any longer as I used to before becoming an interpreter. I need to sample what's coming in. I cannot afford to attend to each and every part of the input. I just sample based on what I anticipate is going to be important. And I pick the bits and pieces and I put them together in the end. If I were to attend to each and every bit, the speaker would be long gone before I would start my interpretation. So this is unaffordable for a simultaneous interpreter. We no longer comprehend that way. The motor center region, the perceptual areas are involved in making responses and detecting the stimuli. Now, you always have to detect stimuli. They're always new. So it's not surprising that we wouldn't find so many changes in that area. A lot of what we really are working with in developing the theory of developing expertise comes to us also from learning theory, especially from motor pattern learning. And that Alex has talked about also about the basal ganglia and the thalamus and the cerebellum. And they're really, really very densely packed, and they have the kind of architecture that mediates the learning of regular patterns. And the stress here would be on regular patterns. We don't always have to deal with regular patterns in interpreting. As a matter of fact, most of the time we deal with, a lot of irregular patterns that are coming in. There are irregular syntactic patterns. People speak off the cuff, or we have non-native speakers whose syntactic patterns may not be the kinds that we would expect from a native speaker. Semantic patterns, some of them might be quite surprising, depending on, our preparation for a conference. All of a sudden somebody says something that just runs completely counter to what we expected based on our preparation. So that may be, patterns that we don't expect. schemata that we don't know about. Students don't really know how to behave in an international conference when, let's say, the treasurer reads his report, or there's voting going on, or amendments are being discussed. I mean, that is all of sorts of parliamentary procedure. These are schemata that we definitely need to acquire in order to operate successfully. So the role of knowledge and preparation is absolutely vital in order for us to recognize patterns rapidly. Anything that's new takes more time, not surprisingly. Now, if regular patterns are really needed for executing these complex tasks, will irregular patterns disturb that proper sequencing? And will that make the execution of the task more difficult or even impossible? Now, anecdotal evidence, and most every interpreter will tell you, that the moment things, become irregular, then you really need to, make sure that your headset is on full and that you're paying attention, and the sampling becomes perhaps a little less spaced out, and you really need to focus on almost each and every word in order to be able to get the gist of it and make sense of what's coming in. The question that we're asking ourselves also is, at what level of pattern irregularity will the adverse effects be felt the most? Is it irregular semantic patterns? Is it irregular syntactic patterns? Can we more easily overcome irregularities in syntactic patterns, or is it easier to deal with accents, so irregularities in phonetic patterns? We don't know yet. We know that any kind of irregularity throws a monkey wrench into the system, and it is precisely that distinguishes an interpreter who is pretty routine from and can handle regularity from an interpreter who can roll with the punches and even land on his or her 2 feet, despite the fact that things have kind of gone awry and it become a bit fuzzy, a bit chaotic. And I'll tackle this right now in terms of what type of expert we're looking for in interpreting. So just to sum up, we have knowledge base that's absolutely vital. And then we have different types of processing strategies in interpreting that are vital for the execution of the task, from comprehension to planning to monitoring, multitasking, but also workload management, something I won't go into right now. It would take us into a different dimension altogether. But it's essentially about, am I going to, starting out in the morning, let's say at 9 o'clock in a conference, am I really going to work a lot during the first half hour, spend all my energy the first half hour, and then be tired by noon, and then I won't be able to work at 5 in the afternoon. So it's partly about, the workload management. You learn interpreting just like any other skill in roughly 3 phases. First of all, you want to just have an idea, well, what does it look like to ride a bicycle or to drive a car? Just get a general idea. What is this like? What is interpreting like? Let me just listen to an interpreter. Let me just look at somebody interpreting. So from then on, once you have a vague idea of what this is all about, comes the very long process of trial and error learning. And I stress the trial and error because in some more traditional learning theories and approaches, the error part had always been looked at as a very negative thing. Whereas we are saying you're never going to become a true expert unless you make mistakes. Yeah, that's the way for you to figure out how not to do it. And what's a mistake for you may not be a mistake for somebody else. You have to learn strategies that fit in with your strengths and weaknesses, and not your teacher's strengths and weaknesses and not your peer's strengths and weaknesses. We're going back to a classroom of 10 and 10 different sets of cognitive abilities. And so it's not about, I'll tell you exactly how to drive down that road, but you need to figure out what strategies are best for you, given the skill level you have and the various sub-skills, to drive down that road. So these are essentially, with a complex cognitive task, the differences in approach. So trial and error learning, the longest part of the phase. And then out of this trial and error learning comes a certain degree of automaticity, of course, for certain subtasks. If you have the beginning of a conference and you have the chairman or chairperson opening the conference, yes, I think many of us can give that speech ourselves. We don't really need to do a whole lot of listening. We've heard it 50 million times, and yes, with some variations on the theme, we could probably do a good job as well, and we have to. So there's a lot, there's a lot of automaticity in certain parts. And that is essential because it keeps the load down on many of the sub-skills. What really, really characterizes, and now that you've seen how sub-skills are important in this whole makeup of an expert, what really is important is how can I focus on individual sub-skills and train those individual sub-skills in order then to make it easier to put everything together. And that is really, I think, the focus of training for interpreting and training for other complex skills is being able to analyze a task, break it up into subtasks, focus on training the subtasks, and then putting it all back together in the end. You don't become necessarily a good interpreter by putting in the hours in the booth. With your headset on and constantly executing the entire task, because it puts the total load on your brain at all times, and you're not going to become better at specific parts by being loaded all the time. So our approach is one of let's take it apart as much as we can. If you've got problems in producing in your native language, then you don't really need to be in the booth to learn how to do that better. If you have problems comprehending your passive languages quickly, you don't need to be in the booth to practice that. You can do that outside the booth and then carry the effects and benefits of it into the booth. So this is in the expertise theory, in the behavioral expertise theory, it's called deliberate practice. Picking one particular weakness and honing that skill until such time as it becomes, quite natural and smooth in its execution. I talked to you about two different kinds of experts, and I just, like to quickly run you through that. There are routine experts, as we call them, people who are quite able and very good at carrying out tasks on a routine basis. There are regular tasks that don't show too much irregularity or fuzziness, and they are very reliable. Given what we now know about interpreting and about language in general, and knowing that regularity isn't necessarily always something that we can count on, we need to have an expert who is capable of dealing with irregularity, who is capable of dealing with the fuzziness, with the not well-formed nature of what comes in, of human discourse which is not always well-formed. A routine expert could easily flounder. The moment it's not regular anymore, the moment it's not what you expected, and that happens with students quite often. The moment it's not what they expected, poof, nothing comes out anymore, and they flounder. So the routine expert, yes, is a skilled person, but that's not what we're looking for. We need somebody who is an adaptive expert. And you don't become an adaptive expert after you've become a routine expert. That's not the case. So just going into the booth and training people up with connotations and, okay, well, this is, how you can produce, good syntactic patterns, and just learn them by heart, and then you go in and you just pull them out of your stockpile, is not going to help somebody become an expert interpreter. Quite on the contrary, we try not to train somebody up that way, because we know there is no easy transition from being a routine expert to becoming an adaptive expert. So the adaptive expert is actually somebody who will be trained on the fuzziness of it all, on the non-well-formed input, on irregularities, and then still being able to extract enough information from what is coming in and make sense of it. So irregularity is what the adaptive expert actually should be thriving on. This is acoustic, auditory pattern recognition, the accents, syntactic patterns that are irregular, semantic patterns, the non sequiturs, and logical connectors that are unexpected. And they should be unexpected because we're dealing with two different languages and two different cultures. The way the French, draw up an argument is certainly not the same way that, the Anglo-Saxons would draw up an argument. And as an interpreter, you have no time online to really, think about that too long. You have to be ready to understand where that speaker wants to go with his or her argument. And it has to be done very, very rapidly. So adaptive expertise is really something that requires multiple perspectives on the problem, flexibility. It requires your ability to think about what you do. We actually train students up to think about what they do and to talk about what they do, so that they are able to become, more introspective and figure out, what is going on. It has a lot to do with how knowledge is represented and how they acquire knowledge before they go in. And I'm quite adamant, almost school teacher-like, in my approach to knowledge acquisition. I check how they prepare for each and every class, because the topic has been announced for the whole term. All topics were announced, and I check each and every time, how have you prepared? And it's interesting. Beginners will draw up an alphabetical glossary, and the more advanced students will have concept maps. So you can see that with increasing expertise, they know what they need to focus on, and that linking the concepts up is much more important for them than having a list of terms in alphabetical order, which they know they're not going to be able to use in the heat of the argument. They're not going to be able to look it up, because that takes at least, 15 seconds, and in 15 seconds a speaker is, a sentence down the road. And you've already missed one sentence, you missed the next one, and then it takes you a while to get back on track. It also requires a fairly deep understanding. I know that some people have said, well, interpreters, they never think about what they say. And while it may be true that we have a poor memory of what we've said in the booth, that is not because we haven't developed a deep understanding of what we've heard. It's just that because of the amount of information that we have to process, we don't have a lot of time to lay down a good memory trace for it. But it's not necessarily because we haven't developed that deep understanding of the argument. So the adaptive experts, we can liken them to the virtuosos, whereas our routine experts are the artisans. They're still good, they're still reliable, you still call them in, to do certain jobs, but you wouldn't really call them in, for doing something very, very demanding. So they're the highly competent. So why do we want the adaptive experts? To deal with the irregularities. We're asking ourselves now, so which parts of the brain deal with the irregularities? And I think Alexis has kind of laid a nice groundwork in saying, well, the basal ganglia, we said they were highly involved in this development of expertise in simultaneous interpreting, and we're now kind of pooling the behavioral evidence together with the neuro-physiological evidence, and we're saying, yes, indeed, this is a place we need to be looking at for people to develop high-level expertise. This might be one of the areas that could be crucial for developing expertise across the board. We also ask ourselves whether we can conclude that anticipation and kind of proactive pattern recognition is instrumental in mediating these very complex tasks. Thinking ahead, however, is only possible if you have knowledge, a foundation of knowledge that will allow you to anticipate what is coming up. If you don't know anything about an area, there's nothing you can anticipate. It's like driving down a road that you've never driven. You won't anticipate where the next turn is going to be. If you know the road like the back of your hand, you can probably drive it in your sleep. So this is exactly the same kind of situation in interpreting. Does the kind of proactive and anticipatory pattern recognition also lead to this very optimal stimulus-response mapping? We don't really have the time to consider 50 million alternatives in interpreting. We need to reduce the number of alternatives down to a minimum, because each alternative that we consider comes with a cost. The more we have to consider, the more time it's going to cost us, and we certainly cannot afford to hesitate. Does it also help us understand the basis of multitasking? Because now we're kind of coming to an understanding that the specificity of simultaneous interpreting in terms of expertise is not necessarily the type of task that the interpreter is engaged in, but is more in his or her ability to multitask, to put all these sub-skills together and execute them more or less simultaneously. And I think this is where we're now headed with our kind of combined theory that we're beginning to develop of expertise, integrating the various data that we've obtained, where we're saying it could well be that in developing a theory of expertise in interpreting, understanding that it's really the multitasking part, that it's not the language transfer per se, but it's the multitasking aspect of this task is what characterizes expertise, not just in interpreting, but probably also with pianists, probably also with chess players, probably also in other fields of expertise. I think this is just a kind of minor addition here, where we can see that the development of expertise in various areas supports, attention supports the recognition of larger chunks, and ultimately bilingual language control, what we've heard from this particular field, further supports this. So the simultaneity is where we've kind of ended up, well, not ended up, but where we've gone with our thinking. This is truly, those are the areas in the brain that we feel are responsible for expertise, at least in interpreting, but we also feel this is most likely going to happen in other areas as well. In our department, we have two other projects going. One of them deals with musical expertise and its relation to simultaneous interpreting. And the data at this point are showing that musical experts who are experts in music and playing an instrument with language abilities, 2 or 3 languages, are the ones who are the most proficient, are higher level experts than interpreters without music. So the musical experts with languages but no interpreting skills are better at multitasking than the interpreters. So you can see where we're looking further afield into other areas of expertise to see, can we find evidence of expertise. We're also looking at choir conducting and orchestra conductors, in sight reading of music, different expertise skills where you have to multitask and integrate different types of sub-skills. And we're hoping that the evidence is, will continue to point us to multitasking as the characteristic of expertise. Thank you very much for your attention. Well, the evaluations that we've done in that particular research project were essentially evaluation of production, of output, and not only in terms of content and faithfulness to the original, in terms of completeness and fluency. That's basically the evaluation. Okay. I think I'm very glad you asked the question, because there's been kind of a sea change in the environment in which the interpreter works. I mean, we still work in highly traditional environments like the UN, and then we have very advanced environments where we already have different technical tools integrated. Working with different screens, for example, more than one screen. I mean, in international courts, that is par for the course. You have, your main screen, maybe of the courtroom, then you have your evidence scrolling perhaps on a different screen, and then you have the live notes from the court. You know what those are. The court reporter types, and your output immediately comes back to you on the screen. So every word that you say immediately comes back. So, you may have 2 or 3 different screens that you have to monitor. Now, there's a price to be paid for that. You remember the slide I had on simultaneous interpretation with the text, because you have visual and auditory information processing going on at the same time. And integrating all of this information comes at a cost. So what are the tools that we would like in the booth? I think being able to at least get those speeches very fast. I think we've managed for as long as the delegates are willing to give up the speeches. But yes, there is hardly any interpreter, most of us are now going into the booth with an iPad, where we've downloaded the speeches, we can quickly access them. We can actually find them faster on the iPad than we can in a stack of 500 pages. Because, you put them on your bookshelf in your library and you click on them and they come up, and you can, type an index word and you find it. So, I mean, there are advantages in that respect. One interesting technical tool that was developed but never really found much acceptance with interpreters, and you would think, it must be wonderful to be able to play back what the speaker said because you missed it. It was developed and it never found much acceptance. A few interpreters, yes, would use it, but most of us no. Because I think it changes the way you interpret. And it changes it from anticipation, which is the hallmark of simultaneous interpreting, to looking backwards. And once the process, is so well trained, it's like the difference between shadowing and interpreting. The interpreters can't shadow very well anymore because they've moved on. They've left this behind, so they're no longer good at this. By the same token, I think we can't go back and change the process itself. That, I think, would be a long training phase again. Other tools, I think, yes, there have been, dictionaries that are, quickly accessible by only using the first 3 letters, and the recognition, works. I think the limit is really what else can we do above and beyond everything that we already need to do. I think many tools would be useful offline. While my colleague is working, then I go in and I find information rapidly. I don't know, maybe Ivana in the back has, she's a colleague of mine, also from your university.
No, I don't know. I think for the moment we have the PC, we have the iPad, we have everything that we have.
Yeah. Online, while you're on task, it's difficult to find information. Even, figures that you've missed and your colleague writes them on a piece of paper can be extremely distracting. Because, you look over there and you have to process what comes from over there. And it has to be taken away somewhere. So the cost is often too great. There's no cost benefit, really. Oh yeah, no, that is, it is very useful indeed. But please, not just 2 lines.
So you can record all of that, and so you can see the whole screen.
Because, okay, so I work with German. Don't just give me 2 lines. The German sentence might be 5, 6, 7 lines long. And what I really need to know right up front is what's at the end of that sentence. Because, going into English, I need that verb at the end of the sentence, and I better figure it out right away. So by having, only 2 lines, no, it's more disturbing than it would be useful. So I think it's also a language pair issue. And you would find the same problem with Japanese or, Russian. The more asymmetrical the language pair is, the more you're going to have to look at larger pieces of discourse for it to be very useful. But the ability to scroll it, this is wonderful now to have whatever is going on the screens in the conference room, to have it transmitted directly into the booth. I would say that that's already a big, big bonus, having the visual representation.
The dictionary can be distracted if it, for example, translates too many words. Like if
Yeah.
you have the transcript and all the words.
The one dictionary I online available is Lingui, that I use most often because it gives me all the words in context. Yes, Lingui, yes. It's the one where I have everything in context. And the word alignment, but I couldn't use it online. Online on task. I use it, when my colleague is working, and then I look it up, and I have just enough time to figure out the right one. It often gives me still too many options, and I wanted to be a little less generous in terms of the possibilities that it offers. But to me, at least, I can identify the context. And align it with the context of the conference very rapidly. And that's the advantage of it. So, yes, parallel corpora in that sense are very useful, but not with 50 million options, please, because we don't have that time. It really needs to, be reduced. So I don't know what one can do, maybe, and this is the ignorant person talking, whether there is a way to kind of reduce the number of options prior to a conference by selecting a certain number of keywords that would also match the conference. And in that way, I would not, instead of getting 50 alternatives, I would only get maybe 10. And 10, I think, is manageable. So that might be a...
So an application for an iPad where an interpreter would first upload the speech on the speakers.
Yeah.
Select the topics, and would translate it from the conference.
Yes.
And then he would have it.
It's a little bit like in translation, where you run the translation through and just get all the terminology out in your first run through, and then the translator can more easily and more rapidly translate. But a rough translation of an original speech would not be useful at all. I personally would absolutely hate to have. It would be more disturbing. We do have to work with those things sometimes. We get the official translation of a speech, and because then you listen to the original, but you already have a translated version in front of you. So you need to line up what you hear in the source language with what you see in the target language, and you still need to check against delivery. You can't have 3 speeches, in front of you to compare. So there are limits to what could be useful online, but this would be one of them.
May I just turn the question around? It's not a question, but just a kind of that some people in machine translation say that bigger improvement machine translation might come when the people working in machine translation will know more about how translators themselves work. How human translators work. So my question would be, do you know enough to give this information to people who work in machine translation? And is it that still some space for more progress?
Well, I think some of the things that I mentioned about sampling the input, for example, I don't know whether that might be a useful approach, but clearly, consciously, we could not process each and every word in the original in order to, make sense. One of the training exercises, for example, for our students is also to print out a speech, let's say, and to take a highlighter and just highlight what they consider to be the key information. Usually it's SVO, but there could be other things as well. And then to take that very same speech and produce a speech only using what they've highlighted. So doing the reverse. It is to make them aware of the fact that, language is utterly redundant. And by eliminating a lot of the redundancy, we as interpreters survive. The moment a speech is no longer redundant, we die. And these are the speakers who spent months, writing their speeches and rewriting and editing out everything that's redundant. And they come to a conference and we have absolutely no margin. It's each and every word all of a sudden is extremely important. And you can't survive like that. As an interpreter, that's why we prefer improvised speech. That's why we don't like, to have read speech, because it is by definition less redundant. And the syntactic constructions are by definition more complex than in improvised speech. So the natural redundancy, but unfortunately, rhetoric, is on its way out. People don't learn how to speak anymore. They don't learn it in school, so we get delegates who have never acquired, to be good speakers. So now we're having to deal with that particular development, and it is very, very tough to live without redundancy. But if there's anything, for machine translation that, in terms of a strategy, that we rely on very heavily, it's redundancy and the identification of redundancy. But that goes straight back to knowledge. How are you going to determine what is redundant unless you have the knowledge base? It's only the knowledge and the background that you have. That's why I'm very, very tough on the knowledge part. That's why I announce all the topics for all the classes in the beginning of term. So there's no excuse. You have no excuse coming to class without knowledge. And I'm not here to teach you knowledge. That's your job. I'm here to teach you interpreting strategies, but not knowledge. And knowledge, I can't teach it unless, you know. So this is maybe a long-winded answer to what we could contribute.
Some further questions or suggestions? Well, 1, 2. Okay.
It's a short question. What do you think it's possible to be a dot translator to the non-native speech or to the non-native language? What's your experience with your?
I think it is. Of course, it depends on what, how you would qualify, top-level interpreter. And I make that distinction between the interpreter and the translator. So I can't really say very much about the translation side of the story. But in interpreting, yes, indeed. What you would not expect an interpreter working into an acquired language, you would not expect, the degree of stylistic smoothness that you would normally expect from a native speaker. You will, accept every now and so often, a certain irregularity. But the message still gets transferred, and there are plenty, and Ivana is one of them, who works into French from Czech on a daily basis when she's in Brussels, and certainly qualifies as a top of the line simultaneous interpreter, and many of them do. So it is possible. However, you would not expect certain things from interpreters working into their acquired languages compared to somebody working into the native language. But the strategies that you need to learn are different. You need to, the skill that you really need to hone and the degree of automation that needs to take place in producing the acquired language is different. If I don't have to produce in the acquired language, I don't need to have, the quickness in my response. I can live without that. But if I have to work into it, I better automate some of those responses. I better get some syntactic patterns automated because I really don't have the time to think about it. But then the comprehension part is easier because it's in your native language, and by definition you would comprehend more rapidly. So it's always kind of balancing things out a little bit. Yeah.
I think it's a very good question. I think basically what we're suggesting is that the expertise comes from the ability to manage essentially the cortical structure. So I think it's worth, I'll show you a picture that's just here, making the distinction between the cortex, the kind of the outside shell of the brain, and the subcortical structures. Now, the subcortical structures are distinctly more ancient, evolutionarily speaking, and they exist, in reptiles, basically. This is known, colloquially as the reptile brain. And these structures are important in the management of everything that goes on in the rest of the brain. And I think the point about expertise sort of waiting on these structures rather than on the more peripheral ones is that these are the ones that manage the rest of the brain's resources. So something that I'd like to point out, some colleagues of ours in Geneva have done some research on musicians, and they've shown that the chordate nucleus, this region here, this is the putamen, chordate nucleus is differently developed in expert musicians compared to amateurs and non-musicians. In fact, what they find, which is consistent with some of the things we've been saying, is that there's a reduction in volume of that structure as people become experts. And there's a graded reduction in volume as people become better and better. And that's very interesting because you might expect it to get bigger. I certainly naively would have expected it to expand, but it seems like it gets tuned. So these structures develop their functionality as a result of the expertise, as a result of what people engage in. And even studies, like, there's a really interesting study from a few years ago where people were trained to juggle. So they trained people over a few weeks to learn to juggle, and that also implicated these very same regions. Also, in concert, of course, with the regions that are implicated in the sort of other aspects of the task. So obviously musicians use bits of the brain that are more sensitive to different auditory characteristics than people doing speech tasks, and a juggler will use bits of the brain that are more concerned with sort of motor tasks than does someone who's doing simultaneous interpretation. But something I'd like to... So I think it's really worth pointing out that everything we do, all our actions, are motor. Everything, our entire interaction with the world is done through motor structures and through motor output. Our only behavior, like even thinking, okay, it doesn't necessarily evoke actual gesture and pattern, but it evolved from a brain system that is responsible for essentially stimulus response mapping. So, think millions of years ago, we were creatures in the world who needed to respond to a changing dynamic environment, and we needed to know whether to run towards or away from something. It was almost as simple as that. And our brain has evolved around this very, very basic, let's call it reptilian kind of capacity. So I think to some extent it makes sense that everything should fall back on the structures that are responsible for gating everything. I don't know, I hope that answers the question. Okay.
checking his output, because what I'm afraid that will happen to me would be like idiosyncratic pattern that would lose the meaning. So no one would understand them anymore. They would just fit very well in my production. So do people, do interpreters listen to themselves just every now and then?
Well, the experts, unfortunately, don't do enough of it. And I think that's one of the reasons why, sometimes the quality of our production goes down, but goes unnoticed by us. And it's interesting because the International Labour Organization just instituted a quality control project. And rather than, having somebody come in and listen to you and then give you feedback on how well or how poorly you did, which is a bit nerve-wracking, when you've been on the job and been hired and, accredited with the organization, and then somebody comes in and checks. What they did was they sent out a note to each and every interpreter who regularly works for them and said, you have 2 months' time to make an appointment with the technician and record yourself during one of the upcoming meetings that you are assigned to and listen to your performance. And that was the end of the quality control. And interestingly enough, it produced a whole host of responses on part of the professionals who then came back to the chief interpreter saying, gosh, I hadn't really listened to myself in a long time. And it was actually a very useful exercise, and thank you for suggesting it. And, I mean, it wasn't like somebody breathing down your neck and making sure you're still performing, but somebody just inviting you to go back and listen to, how you've changed, what you've done in the meantime. Our students have to record themselves each and every time. So we have a technical installation that allows you to do double track recording. So they take with them on a USB key when they leave the booth in the classroom the original discourse, and on the second track their interpretation. And they play it back. They don't need to come back into the classroom. They use Audacity or some dual track recording freeware and listen to themselves, because it's true, you can't really check interpreting unless you have the original to go along with it. But that's one way, where we teach them how to give themselves feedback and how to give each other feedback, feedback to each other, so peer feedback. It's an integral part of skill acquisition. It was the kind of metacognition that I hinted at in an earlier slide.
So thank you again, and thank you for coming.
Thank you.